Let us now study the structures of the functional groups. In this, we are going to take examples of aliphatic alcohols, aromatic ones, and that of ether. In all these cases, we can see a carbon-oxygen bond, and we are also going to see the bond angle which has been made over here between carbon, oxygen and that of hydrogen, and carbon, oxygen, carbon in case of ethers. Let us take the first one. In this particular case, we can see that in aliphatic alcohol, carbon is sigma bonded with the oxygen of the hydroxy group. Here, the bond angle which is made between carbon, oxygen and that of hydrogen is 108.9 degree, which is slightly less as compared to that of a tetrahedral angle of 109.28 degree. Know that the angle is bit less because of a repulsion that we find over here in the case of the lone pairs of electrons which are present over here on oxygen. So these lone pairs repel, because of which we find a slight smaller angle over here in the case of alcohols. Let's go to phenols. Over here the angle is 109 degree, almost similar to that of what we find in the case of alcohol. Here also the lone pair of electrons go to affect the angle which is made between carbon, oxygen and that of hydrogen. Let us see in the case of ether. In case of ether, the angle comes to 111.7 degree. That means the angle over here increases because it has enough, meaning the repulsion over here between the lone pair and the lone pair is comparatively decreased in this particular structure, and hence the bond angle is 111.7 degree. Let us see the bond length. In the case of aliphatic alcohol, the bond length between carbon and that of oxygen is that of 142 picometer. Whereas in the case of phenols, the carbon oxygen bond length is 136 picometer, and if we go to see in the case of our ethers, the carbon oxygen bond length is 141. Now if you can see in case of ethers and in case of aliphatic alcohol, the bond length is almost similar, but whereas in the case of phenols, the bond length over here is less. This is because of the sp2 hybridized nature of the carbon atom which is carrying the hydroxy group. Now in this particular case, it so happens that the partial double bond character on account of a conjugation of the unshared electron pair of oxygen with the aromatic ring, and the second one is the sp2 hybridized state of the carbon atom to which the oxygen is attached. So this is what is responsible for a shorter bond length of between carbon and that of oxygen in the case of phenols.